So if we have rational expressions and we have unlike denominators, the first thing we need to do is first find a common denominator. And we will try to find the lowest one, right? That's reasonable. Okay, so we'll start with our fractions first, so no letters. So 2/3 plus 3/4. So 3 and 4, they're different. I can't add them, so I need to figure out what the smallest number is that both 3 and 4 will go into. Right? So LCD, lowest common denominator. So you might, okay, yeah, that's 12. So I'm going to give you like a little bit more of the math that goes underneath this, right? So maybe it'll help with the understanding later. So, right, we need to build each of these fractions up to have 12 of its as its denominator. So the 2/3, and I'll kind of do a little workspace, right? I need to multiply the bottom by 4 to get to the 12, but I also need then to multiply the top by 4. So 4 over 4 is equal to 1, right? So I'm not changing the value of 2/3 because I'm multiplying it by 1. That keeps it the same. I'm just kind of scaling it up. So the equivalent version of 2/3 that has 12 as its denominator is 8/12. And we'll do the same thing then with the 3/4. So the 3/4, right, I need to multiply it so that it has a 12 in the denominator. So 4 times what? So 4 times 3. That means I need a 3 for the top. Right, so the 3 over 3 is 1. So I'm not changing the value of the 3/4. I'm just scaling it up. 3 times 3 is 9. 4 times 3 is 12. So 9/12 is equivalent to 3/4. So now these are equivalent fractions that I'm going to add together. So 8/12 plus 9/12, common denominator, so we, right, denominator stays the same, and we add the numerators. So 17. So what if I'm subtracting? I have 9/8 minus 1/6. So now I want to find the lowest denominator that both, the smallest number that both 8 and 16 will go into. Right, so you could go to 48, you could just multiply them together, but that's going to lead to some numbers that are bigger than we need. So we're going to look for the smallest one. So I would take 8. My strategy is I take the biggest number 8, kind of do a little work over here, 8, and I'm just going to run through the multiples of 8 until I find something that 6 will go into as well. So 6 doesn't go into 8. The next one up is 16. 6 doesn't go into 16. Next one up is 24. Right, so 8 times 1, 8 times 2, 8 times 3. 6 does go into 24. That'll be my LCD. So now we're going to build everybody up to have 24 as its denominator. So 9/8 becomes, right, so top and bottom by 3 to get to the 24. Okay, 27/24 minus, so then the 1/6, so top and bottom by 4, because 6 times 4 is 24, and 4 times 1 is 4. So now they do have the same denominator, so we can go ahead and subtract those. So denominator, denominator, denominator stays the same. 27 minus 4 is 23. All right, so now, when we have rational expressions, the way we write that one, right, it's going to be a little bit more complicated, but it's the same idea. So 1, a fraction is equal to 1 if you have the exact same thing on the top and the bottom. So 3 over x minus 1 plus negative 4 over x plus 2. So your common, these two, right, denominators, they have nothing in common. No factors in common. Okay? So your LCD is going to be both of those. I need both the x minus 1 and the x plus 2. So then you want to look at that first fraction and see what kind of help does it need to have x minus 1 times x plus 2 as its denominator. So I need to take that 3 over x minus 1 and multiply it top and bottom by the factor x plus 2 that it was missing. And I have a whole lot of binomials, these x plus 1s, x minus 1s, and everything. I'm going to go ahead and wrap those in some parentheses. Sorry, x plus 2, I heard that. So my first fraction, its built up equivalent is going to be 3x plus 6. I'm going to multiply the top, but the denominator I'm going to leave as x minus 1 times x plus 2. So this fraction, this 3x plus 6 over x minus 1 times x plus 2 is equivalent to 3 over x minus 1. It's just now going to have that common denominator I was looking for. Okay, let's do the same thing for the second one. So I have negative 4 over x plus 2. What do I need to multiply it by so that it's going to have that common denominator? So it needs an x minus 1 for the bottom, which means x minus 1 for the top, so that, right, I'm not changing its value because I'm only multiplying by 1. So now there's that common denominator. And on the numerator, I'll have negative 4 times, right, x plus 1. So I'm sorry, negative 4 times x minus 1. So I'll go ahead and do that multiplication. So I have negative 4 times x. It's negative 4x. Negative 4 times negative 1 is plus 4. So now these are the two fractions that I'm adding. They have the same denominator. You can see I didn't leave myself nearly enough room to do these. I'm so sorry. So I'm going to have, hold on, I'm going to grab a sticky so I can finish writing that one out. And then I'll just write the final answer in the box. So I have 3x plus 6 minus 4x plus 4 over x plus 2 times x minus 1. Go ahead and combine like terms in the numerator. I have 3 minus 4x, that's minus x. I have 6 plus 4, that's plus 10. And in that denominator, I'm not going to multiply it out. That's not what we're looking for in this section. So I'm going to leave it just like that. There's nothing common, top to bottom. I don't have any common factors to reduce. Okay, so my final answer here is going to be negative x plus 10 over x plus 2 times x minus 1. Okay, let's do the next one. So, lowest common denominator. Again, when nothing is like a quadratic that we're going to need to factor, the common denominator is usually just both pieces. So you just need to grab both pieces. So x plus 5 times x plus 6. So the 1 over x plus 5. To get to the common denominator, we need to multiply top and bottom by x plus 6. So 1 times x plus 6 is just x plus 6. And then we have that common denominator. Okay, second fraction. And I'm subtracting. So I'm going to have to think about that here in just a second. But I'll just do the 1 over x plus 6 now, and we'll deal with the subtraction here in a second. So times. I need to get to my common denominator. It has the x plus 6. It needs the x plus 5. X plus 5 for the top and the bottom. 1 times x plus 5 is just x plus 5. And then the common denominator. So then it's top fraction minus bottom fraction. So x plus 6 minus, and then I'm subtracting off all of the x plus 5, so I'm going to put it in parentheses. And we have our common denominator. So go ahead and distribute your negative 1. So you have x plus 6 minus x minus 5 over that common denominator. Collect like terms. So x minus x, those are gone, and 6 minus 5 is 1 over x plus 5 times x minus 6. Okay, so now we're getting into some cases where we have like a little overlap. So my LCD, I'm looking for the smallest thing that both x plus 2 squared and x plus 2 will go into. So in this case, x plus 2 times x plus 2, this is just, right, I'm writing it out. This is x plus 2 squared, right? That is our common denominator. Because x plus 2 squared, that's all taken care of up here. And x plus 2, that's already taken care of. So when I look at my fractions to build them up, the first fraction is totally fine. It doesn't need any help at all. It has the common denominator already. The second fraction, right, it has one of those factors of x plus 2. It needs another one. So I'm going to multiply top and bottom of that second fraction by x plus 2. So I have 5x over x plus 2 squared plus 1 times the x plus 2, that's just x plus 2, over x plus 2 squared. So now I have the same denominator. I can go ahead and add the numerators. So x plus 2 times x plus 2. Depends on how much room I have, whether I write it with the squared or I just write them out, right? So then I have 5x plus x plus 2. So 5x plus x is 6x plus 2 over x plus 2 times x plus 2. Now, you should, that was, I don't know if you heard my pause in my voice just a second ago, but I feel like, oh dear, am I going to have something that I have to factor and reduce? So since this is a 6x plus 2, we're going to do a little mental factoring. So we're going to factor the 2 out of both the 6x and the 2 to see if there's something common left in the bottom that we could reduce, right? And there's not. So that's as good as it gets. Oh boy, this one could be ugly. Let's think what that LCD might be. And I'll tell you, a lot of times when, right, you have one factor that's linear, one denominator that's linear, and the other one that's quadratic, that linear factor is going to go into the quadratic factor. So you should go ahead and factor this. So factor x squared plus 7x plus 12. Got it? Right, so that's an x plus 3 times an x plus 4. So kind of like we just did here with the x plus 2 squared, to get my LCD, I would just need that x plus 3 times x plus 4. So right, x plus 3, it has its factor there, and x plus 3 times x plus 4, it has all of it, right, all of its factors there. So that's my LCD. So first fraction, go ahead and build it up. So top and bottom by the missing factor, x plus 4. Go ahead and multiply across the top, so x squared plus 4x. And then your denominator. Second fraction doesn't need any help. I'll just copy that down to save myself some space. So 4x plus 15 over x plus 3, x minus 4. I'm sorry, x plus 3, x plus 4. Go ahead and add your numerators. Just looking to make sure it was add and not subtract. So I have x squared plus 4x plus 4x will be plus 8x, and then plus 15. Okay, so now I have a quadratic factor in the numerator. I should see if that factors. I'm kind of getting a little sense that it might. And it might actually have a factor that will reduce with this one down in the bottom. Let's see, so multiply to 15, add to give 8, so 3 and 5, so that factors into x plus 3 times x plus 5, x plus 3 times x plus 4 for the bottom. So we can cancel those x plus 3s that were common to the top and bottom. Remember, you can't cancel until you factor. So x plus 5 over x plus 4 is our final answer there. Okay, go ahead and pause if you need to. This is a lot. Those were kind of our hard ones. I got a couple of easy ones here to end on. Well, okay, one easy one and one medium one. Here we go. So 2 over 7m plus 7 over 6m. I don't have anything really to factor there. So let's think about what that LCD might be. Right, so your LCD has to have both of these denominators as factors, right, I could write it as 7n times something else, right, to get to my LCD. So I know it has to have at least 7m to be part of the factor, right? And then it also has to have, right, 6m has to go into it. Well, this m is already taken care of for the 6m, but the 6 is not. So 42m is going to be that LCD. So so take a second to think about it. If 42m is the lowest common denominator, then we know that 7m will go into it, right, 6 times, and 6m will go into it 7 times, right? So both of these denominators go evenly into that LCD. Okay, so let's build them both up. So the first fraction, top and bottom, gets multiplied by 6. Second fraction, top and bottom get multiplied by 7, so that my first fraction becomes 12 over 42m plus 7 times 7 is 49 over 42m. Okay, they have the same denominator. Go ahead and add the numerators. That 61. Okay, last one. Now this one, I have a whole number 2, and I'm subtracting x over x squared minus x minus 6. So my LCD is that x squared minus x minus 6. So that 2, right, that 2 we could write as a 2 over 1. So I need to multiply top and bottom. Yes, it does factor, so you could factor that denominator. So top and bottom by that x squared minus x minus 6. Go ahead and do that, guy. Let's see. So I'm going to go ahead and distribute my 2. So I'm going to get 2x squared minus 2x minus 12 over your common denominator. And then it's minus x over that same common denominator. So what do we get when we tidy that guy up? So x squared minus x minus 6 for the bottom. 2x squared, so like terms, so that'll be this negative 2x minus that x, so minus 3x. And then the minus 12. Well, gosh, I'm not sure if that's going to factor or not. It might. I'm just a little bit worried that it does. So 2 times 12, so negative 24 and negative 3. I'm just going to do my little check down here. So is there a pair of numbers that will multiply to negative 24 and add to negative 3? So my factors of 24, and let's see, 2 and 12, 3 and 8, 4 and 6. No, okay, good. It doesn't factor. So since the numerator does not factor, that means it's not going to, I can't reduce, so I can stop.